Hey guys, this is 10.1, day 2, so we're starting with factorial notation. So if n is a positive integer, then the notation n factorial is the product of all the positive integers from n down to 1. So you see n factorial is n times n minus 1 times n minus 2 all the way down. So we can see this in 4 factorial. So it's going to be 4 times 3 times 2 times 1. And that would be 4 factorial. So we have 12, 24, but it starts with your number, and it goes down by 1 each time. The thing to remember is that 0 factorial is going to be 1. So this is a big thing that we use. So when you see that, it's not going to be 0, it's going to be 1. So again, feel free to pause it to make sure you get these notes down. So our first example is a sub n. So I want us to write out the first 4 sequences, our first 4 terms in this sequence. So we have a sub 1. Let's get out of that highlighter mode. So we have a sub 1, which is 20 over 1 plus 1 factorial. So that's 20 over 2 factorial. Again, you probably don't have to write all this out, but I want to make sure you see it. Just 2 times 1, which is just 20 over 2. And we see that that is 10. So let's go to a sub 2. A sub 2 is 20 over 2 plus 1 factorial. So that's 20 over 3 factorial, which is 20 over 3 times 2 times 1, which is 20 over 6. This breaks down to b. We see 2 goes into both of these. 2 goes into this 10 times. 2 goes into this 3 times, so 10 over 3. We're going to go back now and do a sub 3. So we end up with 20 over, and then 3 plus 1 factorial, which is 20 over 4 factorial, which gives me 20 over 4 times 3 times 2. This might be easier for me to cancel at this stage. We know that 4 goes into 25 times, so I end up with 5 over 6. 3 times 2 is 6. And then a sub 4 is going to be 20 over, and then it's going to be 4 plus 1 factorial. So we know that's 20 over 5 factorial. I'm worried you won't be able to see this, so I'm going to bring it back up here. A sub 4 continued. So it's going to be 20 over Give me a second. I'm trying to erase this. Let's see if it works. Not well, at least. Okay. So over 5 times 4 times 3 times 2. And here you know that 5 times 4 is 20. So these go into this equivalent to 1 time. So you end up with 1 over 6. So our first 4 terms are going to be 10, 10 over 3, 5 over 6, and 1/6. Okay, we have a try it yourself. We actually have 3 of them, so I'm going to give you a second. Try one of those out. Okay, so this one says let's write out our first 4 terms. So a sub 1 equals 2 to the first over 1 minus 1 factorial. So 2 to the first is 2 over 1 minus 1 is 0 factorial, which we know is 1. So our first answer is 2. A sub 2 is 2 to the second power over 2 minus 1 factorial. Gives me 2 times 2 is 4 over 1 factorial, which gives me 4. A sub 3, 2 to the third power over 3 minus 1 factorial. So that gives me 8 over 3 factorial, which is 3 times 2, over 2 factorial, which is just 2. And we see once again you get 4 here, because 2 goes into 8 4 times, and then a to the 4th which is 2 to the 4th power over 4 minus 1 factorial. 2 to the 4th, well, we know 2 to the 3rd is 8 times 2 is 16 over 3 factorial, which is 16 over 3 times 2 times 1. And we know 2 goes into 16 8 times. So it gives me 8/3. So my first 4 terms are going to be 2, 4, 4, 8 over 3. Okay, I'm going to clear this and we'll get started on our next one. The next group just says evaluate. So 2 says 10 factorial over 2 factorial, 8 factorial. I believe you guys have a pretty good foundation with this from your Algebra 2 class, but I don't know, so I can't actually ask you, so we'll go through this. So remember, you can expand on a factorial. I can start to write this out as 10 times 9 times, and then you can stop wherever you want to be and then just put factorial after it. So I'm not going to keep listing them out. I have 8 factorial, and the reason I stopped there was because I have an 8 factorial in my denominator. So because I had that 8 factorial and that was the biggest one in my denominator, I knew that would allow me to cancel. So then I'm left with 10 times 9 over 2 factorial, which is 2 times 1, which we know is the same thing as 2. And 2 goes into 10 5 times. So I'm left with 5 times 9, which is 45. So let's try number 3. 3 is n plus 1 factorial over n factorial. So you're going to employ those same strategies. You know you can expand on the top number. It's the bigger one. So it's n plus 1 factorial. So we know we have n plus 1 factorial. Oops, let's not put the factorials in there. N plus 1 factorial. And then we can keep expanding on it. So each one's 1 less. So you end up with n plus 1 minus 1. So what would this be equivalent to? Well, this term here is just n factorial. And therefore, I can again cancel these out. And I'm left with just n plus 1. Okay, let me know if you have questions on those. We're almost done. I know you're excited about that. So our next part is summation notation. So when you guys get to college, some of you might be tempted to join sororities and fraternities. We use summations a lot in that. So that's something. Or you could be in an honor society that has it. But what we're talking about specifically is this right here. So the sum of the first n terms of a sequence is represented by the summation notation. And then we have here. But that symbol, sorry guys, I had to pause it because I hadn't text. But that symbol is your sigma. Oh, that's actually a capital sigma. But so it's represented by the summation notation of sigma, where I is your index of the summation, n is your upper limit. So you notice that this is your index, your upper limit's on top, and the lower limit is going to be 1. Now there are some that start at 0 or other numbers, but generally it's going to be 1. So here's our first one up. You see that you have to expand and evaluate the sum. So what it wants you to do is that you have the summation of 2i squared from I equals 1 to 6 equals, and then you're going to substitute in the value of I starting at 1 until you get to 6. So we have 2 times 1 squared plus, because the summation means we're adding sums. And then here you go 2 times 2 squared plus 2 times 3 squared plus 2 times 4 squared plus 2 times 5 squared plus 2 times 6 squared. And then we get to evaluate the sum by actually performing these. Well, 1 squared is 1 times 2 is 2. Here we have 2 squared, which is 4 times 2, which is 8. Over here you have 3 squared, which is 9 times 2, which is 18. You have to let me write. 4 squared is 16. 16 times 2 is 32. 5 squared is 25 times 2 gives you 50. Plus, and then you have 2 times 36, which is 72. And then we're going to use our calculators to add these up. So I have 2 plus 8 plus 18 plus 32 plus 50 plus 72. 182 is my value. So again, we started with our index at 1, and we built our way up to 6. Here's another expand and evaluate the summation. So I'm going to get started here. So the summation of k equals 3. Notice that our index is now represented by a k, and that's okay. No pun intended there. So now we're going to substitute in our values, but now our lower index is 3. So when we substitute in, you have 2 to the third minus 3 plus 2 to the fourth minus 3 plus 2 to the fifth minus 3. So 2 to the third is 8 minus 3. 2 to the fourth is 16 minus 3. And 2 to the fifth should be 32 minus 3, which gives me 5 plus 13 plus 29. We're going to add these together. 47. Double check my math. Okay, and then we have one more example, and then we have some try it yourselves. Okay, so for our last example, we have our summation of I to the 1, where I equals 1. My index starts at 1, goes to 5, a 4 if we're going to expand. Is there a spot to substitute in an I? No. So every time you plug in 1, there's no place to plug it in. You get a 4. I go to plug in 2. When I go to plug in 2, there's no place to plug it in. I get a 4. 3, same thing. I plug it in. I get a 4. 4, plug it in. There's no place to plug it in, so you're left with just the 4. 5. So what happens here is this is a constant. And since it's a constant, every time you put it in, it's always going to just put back that constant. So 4 plus 4 plus 4 plus 4 plus 4. Well, I have 5 4s, which tells me this is going to be 20. Okay, let's go on to those try it yourselves. So our first one up says expand I equals 1 to 6 of I squared plus 1. Okay, so we're going to start substituting in. I'll change my color so we can see what's happening. So we have 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared plus 1. Now I can go through. I'm going to solve these. So 1 squared is 1 plus 1 is 2. 2 squared plus 1. So 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. 5 squared is 25 plus 1 is 26. 6 squared is 36 plus 1 is 37. Okay, we get to add these up now. I did it once before, but I want to verify that I did it correctly. So 2 plus 5 plus 10 plus 17 plus 26 plus 37. Get 97. Okay, our next one is the sum of k equals 4 to 7 of negative 2 to the k minus 5. Okay, I feel like maybe I will need a little bit more paper, but we'll see. So I end up with bracket -2 to the 4th minus 5 plus -2 to the 5th minus 5 plus -2 to the 6th minus 5. Sorry guys if you can hear my stomach growling. Plus -2 to the 7th minus 5. Okay, so this is making a lot bigger numbers than I would like to work with, but we're going to do it. Okay, so -2 to the 4th. So we know that's the same thing as 2 to the 4th. So 2 times 2 times 2 times 2. So that gives me 16. Since it's a negative to a positive power, that tells me it's going to be a positive 16. So 16 minus 5 for my first term. Plus, and then now this is going to be to a negative power, so now it's going to be negative. And then it's times one more 2, so that gives me -32 minus 5. The next one's to a positive power again, so 32 times 2 is 64. And then we have 2 to the 7th, another 2 times that 64 is going to give me 128 minus 5. Okay, 4, 5, I forgot my negative. That was a close one. Okay, so here we end up with 16 minus 5 is 11. -32 minus 5, so since they're both negative, it's going to be -37. 64 minus 5 is 59. -128 minus 5 is -133. Okay, let's put them all in our calculator. Gives me a -100. Okay, and then we have one last one to do. I'm going to clear this page. So the sum there is going to be that 100. Clear our page. And the last one is once again just a constant. So you know that you have I equals 1 to 5 of a constant term 3. So that means every time you substitute in a number, you have to just get an output of 3. So to the 1, 2, 3, 4, 5. That was a close one. I wrote 5 instead of writing 3. And then we have 3 plus 3 plus 3 plus 3 plus 3, which is just going to be 15. Again, with those constants, it just has an output of the number that's there. Okay, let me know if you have questions. Bye.